Hello friends, welcome back to my YouTube channel. So we are seeing the slope deflection method. We have also solved in my previous video two problems where both the ends are fixed. So we have seen this problem. Here both the ends are fixed and we have solved this problem already. And we have solved one more problem, that is this problem also we have solved in my previous video. I'll give link in the description box. You can go through those videos. So now today we'll solve a problem which is having the one end fixed and another end simply supported. It may be hinge support or roller support. What we have to see is the one end is simply supported. So here simply supported means here our bending moment value is equal to 0 at simply supported end. So now we'll see this problem. The procedure is same. So now we'll see. So our first step is to, as usual, go for the find outing the fixed end moment. So here span A to B is it is carrying the UDL of 20 kilonewton. For UDL, for find outing the fixed end moment of span AB, we have the formula. For span which is carrying the UDL, we have the formula MFAB is equal to minus WL square divided by 12 and MFBA is equal to WL square divided by 12. So by using these two formula, we'll calculate the fixed end moment for span AB as well as BA. So now we'll see. So formula is minus WL square divided by 12. So load is 20. So minus 20 into L is 4 meter, 4 square divided by 12. So simplifying it will come out as minus 26.6 kilonewton meter. Similarly, we will go for MFBA. So formula is same. Only difference is sign. Here negative sign, here positive sign. So it means the answer will come out as positive 26.6 kilonewton meter. So next for span BC. For span BC, MFBC, it is carrying the point load of 30 kilonewton. For this we have the formula. The load is acting at a center. For that we have the formula MFAB is equal to minus WL divided by 8 and MFBA is equal to WL divided by 8. So by using these two formula, we'll calculate the fixed end moment for span BC as well as CB. So now we'll see. So MFBC is equal to, we have the formula minus WL divided by 8. So load is 30 into L is 6 divided by 8. By simplifying it will come out as minus 22.5 kilonewton meter. So similarly MFCB. Here also formula is same, only difference is sign. Here negative sign will come, here positive. So answer will be in positive 22.5 kilonewton meter. This is how we calculate the fixed end moment for span AB, BA, BC as well as CB. So now our first step is completed. So second step is find out the slope deflection equation for each span. For span AB, BA and BC as well as CB. So for that we have the formula MFAB is equal to MFAB plus 2A divided by L 2 theta A plus theta B minus 3 delta divided by L, as well as MFBA is equal to this formula. By using these two, we will calculate the slope deflection. So this is our second step. Now we will see. Second step is to apply the slope deflection method for span AB. For that we have the formula. This for AB we will apply this formula. So MAB is equal to MFAB plus 2ei divided by L 2 theta a plus theta b minus 3 delta divided by L. So our MFAB we got was minus 26.6. Substitute that value, minus 26.6 plus 2ei is not given as it is. So span AB is 4 meter. So 4 into 2 into theta A is here fixed end. At fixed end our slope will be 0. At fixed end our theta value will be 0. So it becomes 0 plus theta b is the, here theta b is the hinged support. It means it has some value. At in support theta value is not equal to 0, it has some value. So keep it as it is, theta b. So simplify this. MAB is equal to minus 26.6 plus 2ei theta b divided by 4. So call it as equation number 1. Similarly for span MBA we need to calculate. For that we have the formula. This MBA is equal to MFBA plus 2EI divided by L 2 theta B plus theta A minus 3 delta divided by L. So now simplify this. MFBA we got was 26.6. So 26.6 plus 2EI L value is 4. 2 into theta B is here in support. Hinge means it has some value, so keep it as it is. Plus theta A is fixed end, it means it is 0. So a sink value is not given, it becomes 0 here, and here also 0 it becomes. So now simplify this. Our MBA will come out as 26.6 plus 2 into 2 4 EI theta B divided by 4 will get cancelled. 26.6 plus EI theta B. Call it as equation number 2. Similarly for span BC. Slope deflection method for span BC we have the formula. MBC is equal to so we need to apply this formula. In case of AB we need to put BC here. MBC is equal to in case of A we need to put B, in case of B we need to put C. So MBC is equal to MFBC plus 2EI divided by L 2 into theta B plus theta C minus 3 dou divided by L. So MFBC we got was MFBC we got was minus 22.5. So substitute that value. Minus 22.5 plus 2EI divided by L value is our span BC. L value is 6. So 6 into 2 into theta B is the hinge. It means it has some value. Theta B plus theta C is also roller. Roller also it has some theta value. So roller also it has some theta value. Theta is not equal to 0 here. So theta C as it is. So it becomes 0. So our MBC is equal to minus 22.5 plus multiply inside 2 EI divided by 6, 2 into 2, 4. 4 EI theta B divided by 6 plus 2 EI divided by 6, 2 EI theta C divided by 6, 2 1 ja, 2 3 ja, 2 2 ja, 2 3 ja. So it will come out as minus 22.5 plus 2 EI theta B divided by 3 plus EI theta C divided by 3. Call it as equation number 3. Equation number 3. Similarly for MCB. So MCB, for MCB we need to put this value in place of BA. This formula in place of BA we need to substitute CB. So MCB is equal to MFCB plus 2 EIL divided by 2 theta C plus theta B minus 3 rho divided by L. So simplify it. Our MFCB we got was 22.5. So substitute that value. 22.5 plus 2 EI L value is 6. 2 into theta C is the roller, it has some value, plus theta B is injured, it has also some value. So it becomes 0. So now simplify this. It will come out as 22.5 plus, I will directly write down here, 22.5 plus, multiply this inside and get cancelled, 2 2 ja, 2 3 ja, 2 EI theta C divided by 3 it will come, and here 2 1 ja, 2 3 ja. So EI theta B divided by 3. So call it as equation number 4. So this is our step number 2. Step 2 is completed. Now step 3 is applying the equilibrium condition. The step is to equilibrium condition. See here a problem, one end as the fixed and another as the simply supported. For simply supported we have to apply the adjoint C. Here one equilibrium equation will exist, that is MCB is equal to 0, because it is simply supported. It may be roller or hinged, no matter what it is, we need to apply one condition, that is MCB is equal to 0. And our second is MBA plus MBC is equal to 0. We need to apply this condition for our problem. So our first condition is MCB is equal to 0. Second is MBA plus MBC is equal to 0. We need to apply these two conditions. Now we will see one by one. MBA plus MBC is equal to 0. This is our first condition, and MCB is equal to 0. This is our second condition. Now we will solve this. Our MBA value we got was 26.6 plus EI theta B, and MBC value we got was minus 22.5 plus 2 EI theta B divided by 3 plus EI theta C divided by 3. So we need to apply these two. So MBA is equal to 26.6 plus EI theta B minus MBC is equal to 22.5 plus 2 EI theta B divided by 3 plus EI theta C divided by 3 is equal to 0. So solve this, it will come out as 2 by 3 plus 1 EI theta B plus 1/3 of EI theta C is equal to minus 4.1. Call it as equation number 1. So now we'll see MCB. So MCB is equal to 0. Our MCB value we got was 22.5 plus 2ei theta c divided by 3 plus ei theta b divided by 3. So substitute this value. 22.5 plus 2ei theta c divided by 3 plus ei theta b divided by 3 is equal to 0. So simplifying it will come out as ei theta b divided by 3 plus 2ei theta c divided by 3 is equal to minus 22.5. So call it as equation number 2. So now what we have to do is solve the equation number 1 and 2 to get the ei theta b as well as ei theta c value. Now we need to solve. So I will show how to solve. Mode equation 5 1. So substitute the value 2 by 3 plus 1. 2 divided by 3 plus 1 is equal to 1 by 3. So 1 divided by 3 is equal to 1 by 3. 1 by 3 is equal to minus 4.1. Minus 4.1 is equal to, our equation 2 is 1 by 3. 1 divided by 3 is equal to 2 by 3. 2 divided by 3 is equal to minus 22.5. Minus 22.5. So solve it. So our first x value will be our ei theta b value 4.7 it is coming. So write it here 4.7, and to get the y value, to get the ei theta c value, solve one more time. It will come out as minus 36.1. So minus 36.1. This is how we need to calculate the ei theta b as well as ei theta c. So our next step is to find the final moment. So by using these values, we'll find the final value. So for that, put ei theta b as well as ei theta c value in equation 1, 2, 3 and 4 to get the final moment. So our equation is MAB is equal to, I will write first all the equations here. So MAB is equal to minus 26.6 plus 2 divided by 4. ei theta b value we got was 4.7. 26.6 plus 2 by 4. ei theta b value we got was 4.7. Put that, simplify, it will come out as minus 24.25 kilonewton meter. Similarly for MBA, 26.6 plus ei theta b value we got was 4.7. Simplified, it will come out as 31.3 kilonewton meter. For MBC, minus 22.5 plus 2/3 of ei theta b we got was 4.7 plus ei theta c we got was minus 36.1. So minus 36.1 divided by 3. So it will come out as minus 31.4 kilonewton meter. So similarly for MCB, 22.5 plus 2/3 of ei theta c is minus 36.1 plus ei theta b is 4.7 divided by 3. It will come out as, by simplifying, it will come out as 0. So these are our final moments. our step 4 completed here. So next is to find the support reactions. Next step is to find the support reactions. Now we'll see. Now to find the support reactions, I have drawn two spans separately. This is AB span and this is BC. For AB we have the moment value MAB value we got was minus 24.25 and MBA value we got was 31.3. So now I will write here MAB value we got was minus, it means anti-clockwise rotating 24.25 and MBA value we got was plus 31.3. So now we'll simplify it to find out the reaction. Summation of moment about A is equal to 0, clockwise rotation positive. So it is anti-clockwise means minus 24 into 25, it is clockwise 31.3 plus usual is acting, so 20 into at a distance of 4, it always act at the distance of L by 2 means 2, it will come 2 minus RB into distance 4, RB into 4 is equal to 0. So by simplifying, our RB value will come out as 41.76 kilonewton. It is moving upward. So now for calculating the RA, summation of all the vertical forces is equal to 0, upward positive. So RA and RB is moving upward. So RA plus RB value we got was 41.76 minus UDL is acting downward 20 into at a distance of 4 is equal to 0. So our RA value will come out as 38.24 kilonewton. It is also positive upward. Similarly for span BA we need to calculate. Here MBC value we got was minus 31.4 and MCB value we got was 0. So I will write here minus 31.4 and here 0. So MBC is minus 31.4, it is anti-clockwise, and MCB 0. So now we'll see the summation of moment about B is 0, clockwise positive, it is anti-clockwise means minus 31.4. So point load is there, so plus 30 into at a distance of, it is acting 3 at a distance of 3 minus RC, it is anti-clockwise, RC into at a distance of from here to here is 6 is equal to 0. So by simplifying it will come out as RC is equal to, by simplifying it will come out as 9.76 kilonewton. It is also positive upward. Similarly for summation of all the vertical forces is equal to 0, upward forces. So here RB and RC is upward, RB and RC are upward. So RB plus RC value we got was 9.76. So one point load is acting downward, so minus 30 is equal to 0. So by simplifying, our RB will come out as 20.24 kilonewton. So now we need to calculate the final value. So here we have only one RA value. So RA value will become 38.24 kilonewton, and for RB we have two here, 41.76 as well as 20.24. So to get the final reaction we need to add these two, 41.76 plus 20.24. So it will come out as 62 kilonewton. So for RC also we have the only one value, that is 9.76 kilonewton. So these are our final values. So now this is our how to find the reaction. Like this we have to find the reactions. So now we'll go for the shear force and bending moment diagram. So that is our last step. So we'll see. So I've already drawn here. So I've drawn the pre-body diagram of bending moment. This is for UDL. Our diagram will be parabola. For this it will come like this. Triangle. For point load it will be triangle. So to find out this maximum height, we have one formula, that is WL square divided by 8. W is your 20 and L is 4 divided by 8. So by simplifying it will come out as 40. Maximum height is 40. And for this triangle, to find this maximum height, we have the formula WL divided by 4 is equal to W is 30 and L is 6 divided by 4. By simplifying it will come out as 45. The maximum height of this is 45. This is our body diagram of bending moment. Now we will see the net bending moment. So for net bending moment, we'll by using the value of moments which we have calculated, final bending moment value, by using these values we'll draw the net bending moment diagram for MAB. So we need to see the first point always. So here our first point is A. So at point A we have the value minus 24.25. So for this is our point A, we have the value minus 24.25. So see here, always for drawing the net bending moment, our negative value also comes above the neutral axis. So for point A, our value is minus 24.25. So it means it comes above the neutral axis. It means it comes here. So and for point B, so MBA value we have 31.3. So here first point is B. So at point B 31.3. So at point B means here 31.3 means it comes above this line and below this 40. 31 means it comes here at point B. Similarly for BC, our first point is B. At point B our value is minus 31.4. So minus 31.4 means, see here at point B the negative value will coming above the neutral axis. So it comes here. So for CB we have the value 0. 0 means it will come here only. So here at point A our value will come, negative value will come above the neutral axis. At point B our positive value also comes above the neutral axis. This is the sign convention. For drawing of the net bending moment we need to see this. If negative value comes we need to draw the above the neutral axis only. So these are our finds. Now we need to join it. I will join. So this is the net bending moment diagram. This is how we have to draw. So now we'll go for the shear force diagram. So by using these final reactions value, we'll draw the shear force diagram. So see, RA is 38 point here. RA is 38.2. 38.2 means it comes here. 38.2. So from here to here, so here when UDL is there, it means it comes below here. So what we have to do is, see here 38.2, 38.24 our RA value is 38.24 minus, usually UDL is acting there, so subtract this 20 into at a distance of 4 it is acting. If you do this, it will come out as minus 41.76. Minus 41.76 means it comes here. So now we need to join this line. It will come like this. Again here reaction RP is acting. It is 62. We need to, it is upward means we need to add it plus 62. So it will come out as 20.24. Above the neutral axis it comes here. So it comes here 20.24. So it is 41.76. So here to here nothing. Again we'll draw this. Here on point load is acting downward. It means we need to subtract in this value minus 30. It will come out as minus 9.76. So minus means it comes here. So 9.76. So now here reaction RC is acting. It is upward. It means we need to add it 9.76. It will come out as 0. So our diagram will touches the axis. So it means whatever we have calculated till now is right. When our last value comes 0, this line touches this neutral axis. It means whatever we have calculated till now is right. This is the shear force diagram. So this is how we need to draw. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.